Hi, this is Team 659 Majai, and our project is Neurolinguistic Assistant. This is our co-designer, since we haven't asked for his permission to put his image here, so currently we only have his information. The patient and our co-designer is Mr. KD. He is 70 years old, and he is a right-handed male. He has a history of hypertension. 6 months ago, he had a stroke in broadcast region, leading him to having right-sided arm and legs weakness. He also had speech deficits. We have interviewed him and we found that he enjoys watching basketball and American football. He also loves to read the Bible because he used to be a pastor. His favorite food is kafir kai, Thai food. Currently, Mr. Katie is the patient and the person that we need to help. But most of the thing and most of the interviews, we interviewed Pastor Sirishai, which is our coach and our co-designer too. He's the doctor and Mr. Katie is his patient. So, based on their needs in the interview, we split their needs into three categories based on Beaverworks courses: must have, nice to haves, and neutral haves. The highest priority is must haves. Mr. D's family members need a device that could translate what he's trying to express. For nice to haves, they want a device that had a suggestion system that can propose answers based on his daily schedule. For example, usually you're gonna eat at 5 p.m., then the device have to suggest or remind his family member to take care of him at 5 p.m. And finally, at the lowest priority, they want to have a device that had the Bible and able to watch basketball games. So this is our single sentence product objective. Our final product goal is to enhance the communication between the co-designer, the patient and his family, while trying to customizing the device to incorporate his favorite things. Initially, we came up with the idea that we use brain-computer interface to capture EEG signals, and then we will use deep learning models to interpret and decode the EEG signals to understand what is the patient trying to say. However, after receiving feedbacks from Mr. Hosisiu, we changed our approach and narrowed down our project. We decided to let him choose what he wants to say by selecting the cards on the device. So he can communicate his thoughts and respond to the questions more easily. This is the plan for the next 3 weeks of our team. So you can have a look at it. This is our product requirements. The device have to be touchscreen and had loudspeakers. It has to be a large display from 10-inch to 12-inch. It's able to run an operating system, have a long battery life, and also have the ability to work offline. This is our lo-fi prototype for the project. The last picture is our sketches for how the monitor is mounted on his wheelchair using a VESA mount. The right pictures are our sketches for the user interface of our app. So for example, if you want to click on health card, so health is the main category, you click on health, and inside health there are 8 other cards. so he can click on that. This is also our sketches for the device. The left picture is the 10-inch screen, and the small rectangle here is the place where we're gonna attach the Raspberry Pi with its battery. We decide to use the VESA mount, and in every VESA mount there is a place like this. Because the VESA mount was built for large monitors like a TV, we decided to use VESA mount for our device by taking out the red thing here, and then we will 3D print the blueprint here, the blue thing here, to fit the screen, our 10-inch screen. And we have to buy a case for the Raspberry Pi and the battery. As you can look at the picture, the Raspberry Pi is lying on the battery. The battery is down here, and the Raspberry Pi is here, because the Raspberry Pi required the power supply for it to work. However, because we attach Raspberry Pi on the device on the wheelchair, we need to buy a battery supply so it can work in long hours. Those are risks that we describe and we discuss about. First, the device may fall or break. Secondly, the device, the battery, and the charging risk. Thirdly, it have to make sure that device can tolerate the weather or liquid damage. And number four, we have to make sure that the movement is comfortable for the co-designer. So this is our order list. We use Raspberry Pi Model 3 B Plus because it's cheap compared to model number 4 and model number 5. And then we use a micro SD that sell and buy with the Raspberry Pi model. To print the outer case, we buy a 3D printed filament, and we use VESA monitor mount. The reason we use the VESA monitor mount but not the client mount like tablet is because we want to make sure that we can attach the device, the display, to the mount with nails instead of clamps, so it makes sure that they won't drop. And then we have to buy a portable supply, since I explained before. This is the power supply for Raspberry Pi. And lastly, we buy a 10-inch touchscreen display for the Raspberry Pi. And the estimated cost for our project is $240. And in that case, we're gonna use our personal fund, so to about $115. And this is the end of our presentation.